What's up, everybody? Last opportunity of the marking period coming up right here. I am not going to do half this worksheet like I did half the last time. I'm going to do a couple problems, and then you're going to finish it. Good news for you, you have all the resources of every video and worksheet that I've given back to you at your disposal. So, number one, I'll do A and B. If you draw two cards from a standard deck of cards, what's the probability of the following? And then I make sure I understand that this is with replacement. A black card, then a heart. So I'm drawing two cards, so it's got to be a black card, and then it has to be a heart. Black cards are color, there's 26 of them, so 26 out of 52. Times, hearts are a suit, so there are 13 of those, so 13 out of 52. And that's it. Because it's with replacement and it has to be in that order, I'm done. The king, a king, and the four of spades in any order. So I could draw king and four spades. So I'll do king and then four of spades. Alright, so there are four kings in the deck. So 4 out of 52. Then the four of spades is a specific card. There's only one of them, so just 1 out of 52. However, it could be in any order. So I could do king, then four spades, or I could do four spades, then king. So I need to take these fractions and multiply by the two ways that there are to arrange them. That's all I will do with number one. Number two, I'm going to do part A, draw three cards from a deck. So with replacement once again. So it's got to be a red card, then a queen, then a 3. So red, queen, 3. There are 26 red cards in the deck out of 52. There are 4 queens in the deck out of 52. And there are 4 3s in the deck out of 52. And because it has to be in that specific order, I'm done. Number 3, a box contains 5 white and 15 green marbles. So that's 20 total marbles. What's the probability of drawing a white marble and a green marble in any order, and then it's mixed up here with replacement? So white and green. So white marble is 5 out of 20. Because it's with replacement, it's 15 out of 20. But then it says in any order. So I could do either white, green, or I could do green, white. So I need to multiply these fractions by 2. That's what I multiply it for. A white and a green in any order without replacement. So I'm going to do white, I'm going to do green. There's white, there's green. So white marble once again is 5 out of 20. Green this time is going to be automatically out of 19. Why? Because I am doing it without replacement. But I haven't chosen a green marble yet, so there are still 15 of them because I haven't chosen them. And I'm still going to multiply by 2. Why? Because it could be in any order. So I could be white, green, or I could be green, then white. And so that's what I'm going to do for number 3 with you. That's all. Make sure you recognize when you do things without replacement, the denominator automatically goes down by 1. The numerator sometimes does and sometimes does not, depending on if you've chosen something of that variety already. If you roll a 6-sided dice 2 times in succession, find the following. What's the probability that you roll a 6, then not a 6? So 1 6-sided dice, then something else. So it's got to be a 6. And then it's got to be, watch this, not a 6. Remember that? Oh, with a line over it? That's the complement of 6. So there's a 1 out of 6 chance of rolling a 6. Then there's a 5 out of 6 chance of not rolling a 6. And it's got to be in that order. So I'm going to leave that one right there. Okay. All right. I am going to do this. If you roll a 6-sided die twice in succession, I'm going to leave that one to you guys. A box contains 7 white marbles and 8 red marbles, so a total of 15 marbles. What's the probability of drawing the following? But this entire question is without replacement. Okay, I will do part A with you. A red marble, then a white marble. So, a red marble, then a white marble in that order. Red is 8 out of 15. Immediately, my next draw is only out of 14. But I haven't drawn a white marble yet, so there are still 7 of them, with times in the middle. I'll do one more with you. 2 red marbles. So red and red. So what's the probability of the first red marble? 8 out of 15. What's the probability of the second red marble? Immediately, this is only out of 14. But because I drew a red marble already, there are only 7 remaining. There were 8 red marbles, now there's only 7. Okay, going on to the next problem. And I think that you are starting to get this right here. Number 7 is without replacement. Okay, let's do one problem from this right here. I will do the probability of drawing the following. Now, it doesn't even give a number of chips, so I could draw as many as I want. So, you know what? I'm going to do E. 2 red chips, then 1 blue chip, then 2 white chips. So red, red, blue, white, white. All right, let me scroll up so I can actually see what I have here. There's 7 plus 3, which is 10. 10 plus 11, there are 21 chips to start this. So red, red. So that's 7 out of 21. Because I'm doing this without replacement, I might as well make my life easy right now. Let me do all of my denominators right now. So then 20, then 19, then 18, then 17. So then I know I'm done with the denominator. There were 7 red chips. Now there's only 6 remaining. We haven't chosen a blue one yet, so there are still 11 blue chips remaining. And there are 3 white chips to begin. Once I choose one, there's only 2 remaining. Fundamental counting principle, I multiply in between. And because that is the specific order, I'm done with letter E. Okay. Draw 2 cards from a deck without replacement. 2 spades. So, a spade and a spade. Spades are a suit. So there are 13 spades out of 52 to begin. There's only 51 cards left the second time around. Since I drew a spade on the first pull, there are only 12 spades remaining for the second pull. Okay. Number 9, draw 2 cards from a deck. Once again, without replacement. An odd number card and a face card in any order. Alright, so I'll do that one. So an odd card and then a face card. What are the odd number cards? There's no 1, but there's 3, 5, 7, and 9. Each of those, there's 4 3s, there's 4 5s, there's 4 7s, and there's 4 9s. So there are 16 total odd number cards. So that's 16 out of 52. Because it's without replacement, there's only 51 cards the second time around. How many face cards are there? There's jacks, queens, and kings. And there's 4, 4, and 4 of those. So that's 12 face cards out of 51. I will leave that one right there. Last but not least, 5 cards are drawn from a standard deck. What's the probability of, oh wait, I'm sorry. Let's go back to number 9. And an odd face card in any order. So I apologize. I need to multiply this by 2 because I could do odd, then face card, or I could do face card, then odd. And so that's why I'm multiplying by 2 right there. Oopsies. Last but not least, number 10. 5 cards are dealt from a standard deck. And the one thing it assumes, it doesn't say at number 10, it should be without replacements. I'm going to stop right there. All right, the rest of this is your quiz. You can handle it.